On your ACT, usually one of the 4 trig problems has to do with the law of sines. Now, sometimes the law of sines is explicitly stated, meaning it's actually written out, and other times, such as in this problem, the law of sines is written out in words, which is probably less helpful. But the law of sines says this. It tells us that for any triangle ABC, the sine of A over little a equals the sine of B over little b equals the sine of C over little c. Now, in any triangle ABC, such as this one here, big A means this guy right here. And then little a is actually across from big A. So that's little a over there. It's a side length. Same with B. The sine of B would be the sine of this 97-degree angle. And then little b is 18. That one's stated. It's given. And then the sine of C would be the sine of, we could figure out what that is, you know, because they all have to add up to 180. And then little c is over here. So this is actually side little c. And this tells us that we can create a proportion from these 3 equivalent ratios any way that we want. Now, the Pythagorean theorem is used when we have a right triangle. That's used to find a missing side length, a squared plus b squared equals c squared. However, when our triangle is not right, such as this triangle here, we use the law of sines. So there's the difference. Right triangle, to find a side length, use the Pythagorean theorem. Any other triangle, use the law of sines. So we are asked again for an expression. So this is a non-calculator problem. We just have to do a little bit of rearranging, set up and rearrange. So we're looking for the length of BC, which is actually little a. So we're definitely going to be using this piece, and we have to figure out which of these other ones we're going to use because we can't have 2 equal signs. We just need to use 2 fractions, not 3. So let's look and see what pair we have. We can't use this because we don't even know little c. But it looks like we know both the angle of b and little b. So let's use that. We're going to actually use this piece right here, these 2 fractions out of the 3, and we don't really care about the sine of c over c. Okay, let's fill in what we know. We know that the sine of A, which is actually the sine of 21 degrees, over little a, which is what we're looking for, equals the sine of B, which is actually the sine of 97 degrees, over little b, side length of 18. And we've just created a proportion. A lot of you enjoy solving these, at least my students did when I was in the classroom, and because everyone always wants to cross multiply. So lucky for you, that's what you get to do now. So we know that A times the sine of 97, and again, don't even put in your calculator sine of 97 or sine of 21. We don't care. Look at your answer choices. They're all written out that way. Okay, and that's going to equal 18 times the sine of 21 degrees. In order to solve for A, we need to get rid of this times sine 97, so we're going to divide both sides by the sine of 97 degrees. So A actually equals 18 times the sine of 21 degrees over the sine of 97 degrees. That's our expression for the length of BC. Let's look and see where it is. It's actually answer choice A. Now notice they all look pretty similar, but using the law of sines, setting up your proportion and cross multiplying can give you the answer. Another little trick that the ACT might throw at you in a law of sines problem is they might have you figure out, you might need to figure out angle C. And of course you know that 97, 21, and whatever this guy is over here have to add up to 180. So you are well prepared in order to do that as well. Answer choice A is our final answer.